All right, this is your second packet, and this first page is on coordinate translations. So they tell you to plot the points A, B, and C, and you need to be sure and label those points. So A is at 5, 6. B is at 1, 2. And C is at 8, 4. And then they're telling you to translate the triangle 6 units to the left. So that means every point is going to just move to the left. 1, 2, 3, 4, 5, 6. So this is going to become B prime. And the prime is how you mark the image point. So A is going to move to the left. 1, 2, 3, 4, 5, 6. And that's going to become A prime. And C prime, or C is going to move to the left. 1, 2, 3, 4, 5, 6. So the A prime is at -1, 6. B prime is at -5, 2. And C prime is at 2, 4. Now, the question is, how did the coordinates of the triangle ABC become the coordinates of triangle A prime, B prime, C prime? So the x values, if you look at the original x values, 5, 1, and 8, so 5 becomes -6. Oops, sorry, I got those mixed up. That should have been -1. So 5 becomes -1. -1 becomes -5. 8 becomes 2. So all the x values decreased by 6. But the y values, 6, 2, and 4, stayed 6, 2, and 4. So the y values stayed the same. So if I were going to write this, a couple of ways I can write this in function notation. I could say the original xy goes to, that's what the arrow's indicating, it goes to x minus 6 and y, because the y stayed the same. Or with a translation, you can do a capital T, and then subscript component form. Component form looks like an order pair, but instead of curved parentheses, they're pointed. And you're moving that x value -6, but the y stays 0. So that just tells you that you're going to the left 6, but there's no vertical change. So now you're going to do the second one by yourself. And then you're going to answer these questions. So if the coordinate in this example that we did, if the coordinates are translated to the left A units, then x is going to be x minus A, and the y didn't change, so it stays a y. And then you can continue to answer the other parts on your own. But now I'm going to move to the coordinate reflections page. And you're going to graph point A, which is at -3, 8. B is at 1, 2. And C is at 5, 10. And those are my pre-image coordinates for triangle ABC. The pre-image just has the regular letters on them. The image is going to have the prime, or it looks like an apostrophe symbol. So we're going to reflect this over the x-axis. So I'm going to highlight the x-axis. Not saying you have to highlight it. I'm just doing it for emphasis. So B was 2 units above the x-axis. So when I reflect it, it's going to be 2 units below the x-axis, and that's going to be B prime. Be sure that you are labeling each one of your points. Don't just mark the points. If they have a label, a letter label, ABC, you label those and you label their images. So A is 1, 2, 3, 4, 5, 6, 7, 8 units above. So it's going to go 8 units below the x-axis, and that's A prime. C is 10 units above the x-axis. So it's going to go 10 units below the x-axis. I really should use a ruler. All right, so A is at -3, -8, or A prime is at -3, -8. B prime is at 1, -2. And C prime is at 5, -10. So some things that I want you to pay attention to is how are the x's changing or staying the same, and what's happening to the y's? Are they changing, and how are they changing, or are they staying the same? So the x coordinates stayed the same. And the y coordinates became opposite. So change sign. So keep thinking about these. So if I have x, y, and you can use the first packet to kind of help you with this. Now what happened when I reflected over the x-axis, the x stayed the same, but the y became opposite. Okay, so think about that as you're answering the next question. You're doing the next one by yourself, and then you're coming up with some conclusions and some conjectures here at the end. On the next page that says more coordinate reflections, this time we're going to reflect over the y-axis. So we're going to start out by plotting point A is at 4, -2. B is at 1, 2. And C is at 5, 10. So this time we're reflecting over the y-axis. Now, one thing I want you to pay attention to is your pre-image point and your image point. They're going to be the same distance from the line of reflection. So in this case, my y-axis is my line of reflection. So A was 1, 2, 3, 4 units away from that line. So A prime on the other side has to be 1, 2, 3, 4 units away. So A prime is at -4, -2. B is 1 unit from the line of reflection, so B prime is 1 unit from the line of reflection. So it's at -1, 2. C was 5 units from the line of reflection, so C prime is going to be 1, 2, 3, 4, 5 units away from the line of reflection, and that's at -5, 10. And notice with a reflection, it looks like the figure has just been flipped over that line of reflection. So in this case, going over the y-axis, the x coordinates, we went from 4 to -4, 1 to -1, 5 to -5. So they changed sign. And the y coordinate, -2 stayed -2, +2 stayed +2, and 10 stayed +10, so they stayed the same. So my xy goes to the x changed sign, so it's opposite, and the y stayed the same. So again, on this one, you've got another one to do, and you've got some conclusions or conjectures you need to make at the end based on those. All right, we have coordinate reflections one more time. But this time, we're going to graph over the line y equals x. So we need to graph that line first. So that line is every point, every x coordinate and every y coordinate have the same value. So 1, 1, 2, 2, 3, 3, so on. So all of these are going to have the same value, x and y. So that's y equals x. That is that equation. So now we're going to graph point A, B, and C. So 2, -1 is A. B is at 1, -6. And C is at 9, 1, 2, 3. Now they want us to reflect this one. So this one's kind of a little bit tricky. But what I'm going to go ahead and tell you what's going to end up happening when y equals x, when you reflect over that line, the original x and the original y switch places. So instead of A being at 2, -1, A prime is going to be at -1, 2. Actually, let me change color on that. So -1, 2 is where A prime is going to be. B prime is going to be at -6, 1. And C prime is going to be at 3, 9. So on this one, the x and y coordinates switch places. So my original x, y coordinates become yx. You're going to do the next one by yourself and answer those questions at the end. And now we have some rotations. Now, rotation can be a composition, meaning more than one, of two reflections. So if I graph the points 8, 3, 3, 1, and 9, 7. First, we're going to reflect it over the y-axis to get triangle A prime, B prime, C prime. So my y-axis is that vertical. So B is 1, 2, 3 from that line. So we're going to go 1, 2, 3 from that line to get B prime. So I'm going to fill in here. So we'll do B prime is at -3, +1. A is 8 units from the y-axis. So A prime is 8 units from that y-axis. So A prime is at -8,3. And then C prime is 9 units from that y-axis. Or C is 9 units, so C prime is going to be 9 units. So it's at -9, 7. Okay, now we're going to take that answer and we're going to reflect it over the x-axis to get A double prime, B double prime, C double prime. So here is my x-axis. So B prime is 1 unit above, so B double prime is going to be 1 unit below. So that's at -3, -1. A prime is 1, 2, 3 units above, so it's going to be 1, 2, 3 units below. That's A double prime is at -8, -3. And C prime is 7 units above, so I'm going to go 7 units below to get C double prime. And that's going to be at -9, -7. So if you were to look at your pre-image to your final image, you will see that it's a rotation. It looks like this figure in quadrant 1 was turned or rotated to become the figure in quadrant 3. So what's happening here is my original XY from my pre-image is going to go to, and this is going to be my image, the final image. So the original 8 became -8, the original 3 became -3, and 9 became -9. So the original X changed sign. And the original Y, 3 became -3, 1 to -1, 7 to -9, it changed sign. Now we've got to decide how much of a rotation that was to get it from here to here. So next week when I come back, we're going to start using patty paper, just little pieces of tracing paper. And I'm tracing where the X and Y axis intersect. And right now I'm going to trace those points, the original from my pre-image, and then draw in that triangle lightly. So I'm going to choose the origin to typically, most of the time, that's going to be your center of rotation. And if I rotate it to where the X and Y axis line back up, that's 90 degrees. Rotate it again until they line up, and that's 180 degree rotation for the pre-image to line up with the image. So this was a rotation of 180 degrees. And it doesn't matter if I go counterclockwise, which is a positive rotation, or if I went a negative 90 and a negative 180, I still get the same end result. I get to the same location. So 180 degrees does not need a direction to be told. So you could call it rotation of 180 around the origin. Now that's writing it out in words, but like in that last packet, we talked about some different notation. So capital R around the origin, 180 degrees is a different kind of notation. This one we call coordinate notation because you're specifically talking on a coordinate plane. But sometimes we'll do rotations that are on or off the coordinate plane, and this notation fits either one of those. You're going to do the next one and answer the fill in the blank at the bottom. And then on the next page, you have the more coordinate rotations, and you're going to do those as well. You're going to have to graph your line y equals x and go back and look at your reflections pages to help you with that.